Hey guys, go ahead and get out some paper so we can look at discriminant and quadratic equation. So just as a refresher, your quadratic formula is used to find your solutions, and your solutions are those x-intercepts or zeros of the quadratic graphs. And typically in the past you would have used the quadratic formula when you couldn't factor, when you thought factoring would have been prime. But now you're probably going to want to use it more as a go-to just because it's easier to get all answers, especially when we're dealing with our imaginary number I. So before you can use quadratic formula, you have to have your equations in standard form, meaning a, b, and c are on the same side, and then you have your equal 0. So first thing we're going to talk about is the discriminant, and the discriminant is actually part of the quadratic formula. It's the b squared minus 4ac part, and the discriminant will tell you different things about the kinds of solutions that you'll have. So if your discriminant ends up being positive, what that means is that you're going to have two real solutions. If your discriminant is a positive perfect square, it means you could have factored, or if it's a positive non-perfect square, you would want to use your quadratic equation. Next thing you can get is a discriminant that's negative, and that means you're going to have two imaginary solutions, and the reason is because when you see the quadratic formula, b squared minus 4ac is in a square root bar, so if you get a negative, that means you're taking the square root of a negative, so that's where you're going to get those imaginary solutions. We're not going to call it no solution now that we know how to solve with I. And then last, if you get 0 as your discriminant, means there's one real solution, and because there's only one x-intercept, that means it was the same two factors, which give you that same one solution, and that really means that this is a perfect square trinomial, meaning you could have factored it that way. So here's just another little visual. You can kind of see it here. If the discriminant was positive or greater than 0, you get those two solutions, meaning you're going to have two x-intercepts. If you get the discriminant that is 0, that means you had a perfect square trinomial because you only end up with one solution. Since when you have these kinds of perfect square trinomials, your factors are exactly the same, which means your solution is the same and you only get one of those. And then last is when you get that discriminant that's a negative, and what it looks like as a graph is it kind of looks like a parabola just floating up above the y or the x-axis, meaning it never crosses through. So normally we would have said no x-intercepts, and there are none, but we do have solutions, they're just non-real. So we're going to just practice getting your discriminant out of these three here, just to tell what kind of solutions we'd have. For the first one, it's already in standard form. A is 9, B is 6, C is 1. We're going to go ahead and do 6 squared, or B squared, minus 4 times A times C. Something to keep in mind here, make sure you put the number in parentheses, especially when you square it. So this becomes 36 minus 36, and we get a discriminant of 0. So this means it is one solution, and that would have been a perfect square trinomial if we had to factor it. Next one, we've got A is 9, B is 6, C is negative 4. So we're going to go ahead and do 6 squared again, minus 4 times A times C. This time C is a negative. So now we end up with 36 plus 144. And then we're going to go ahead and add 144 and 36. We get 180. Since it's a positive number, not a perfect square, we have two real solutions. You cannot factor since that's not a perfect square number. And then the last one, A is 9, B is 6, C is 5. So we'll go ahead and do 6 squared minus 4 times 9 times 5, which will be 36 minus 180. And we're going to end up with a negative solution of negative 144. And because that's a negative, that means there are two non-real solutions, meaning this is going to be I whenever we actually do our quadratic equation. So here is your full quadratic formula. You're going to want to go ahead and write it down. It's x equals the opposite of b, plus or minus. Because of that square root bar, it's plus or minus. And then the square root of b squared minus 4ac, so there's your discriminant, all over 2a. Your steps for solving with this would just obviously be to do the equation in standard form, identify A, B, and C, plug them into your equation, and evaluate. While you're evaluating, you're going to want to simplify your radical. So within your square root bar, you're not necessarily going to take the square root unless it's a perfect square number. If it's not, you're going to just simplify the radical the way we were doing in class, and then you'll write your solutions out. Keep in mind your solutions are really representing those x-intercepts, so you could always graph it and check those x-intercepts to check your solutions. So this first example, we're going to go ahead and put this into standard form first, so we need to bring over 35, which makes it a negative. Identify A, B, and C, so A is 3, B is 8, and C is negative 35. And then we're going to go ahead and plug it into our quadratic equation. So we should get negative 8 plus or minus the square root of 8 squared minus 4 times 3 times negative 35 all over 2 times 3. So we'll go ahead and simplify a little bit from here. I normally just simplify the stuff inside the square root bar, which would technically be considered your discriminant, because that's going to tell you how many kinds of solutions you're going to end up having, and then it makes it pretty easy from there, and we can simplify the denominator as well. So we end up getting 64 minus 4 times 3 times 35, which should become plus 420 all over 6, and then I'm going to go ahead and one more step, and I'm going to actually do 64 plus 420, and that should give me 484 all over 6. So from here I would pay attention to that square root of 484. If it's a perfect square, you can take it. If it's not, you're going to simplify it as a radical. That actually is a perfect square. Square root should be 22. So because it's a perfect square and we have all numbers here, real numbers, we can actually finish simplifying this. We'll do negative 8 plus 22 over 6, and then negative 8 minus 22 over 6. And we should get 2 real answers. So negative 8 plus 22 should be 14. 14 over 6 can just be reduced down to 7/3, and then our second solution should be negative 30 over 6, and that is just negative 5. So that means if you were to graph this, your two solutions would be at 7/3, or about 2 1/3, and the other one would be at negative 5. And because these are actually real solutions, you could technically plug these back into the original equation and just make sure it works as well. That's what solutions will always do. Okay, let's take a look at the second one together. So 2x squared plus 2x minus 3, if we put this into standard form, equals 0. So then a would be 2, b is 2, and c is negative 3. So again, I'm going to just plug all this into my quadratic equation. And we end up with negative 2 plus or minus the square root of 2 squared minus 4 times 2 times negative 3 all over 2 times 2. So again, I'm going to go ahead and do just my discriminant, 2 squared minus 4 times 2 times negative 3. So our discriminant ends up being 28, and since that's not a perfect square, that means you can't factor this, but because it's positive, we do end up with 2 real solutions. So again, because we can't necessarily take the square root of that since it's not a perfect square, we're going to simplify it as we would simplify any radicals. Look for perfect square factors. I know I have 4 and 7 as perfect square factors, and I could take the square root of 4, which will give me 2. So we end up just simplifying that radical. And our final answer for this, we want to leave like this. The reason we leave that, because that's more accurate. When you take the square root of 7, you're going to end up cutting it off since it's irrational, and then you're going to end up rounding a bunch, and we want to be exact with our answers, so this is the best way to be exact and the easiest way to simplify this. And just to point out really quick, you may see on a multiple choice test where they actually did simplify one more time by reducing, since your numerator has negative 2 plus or minus 2 times the square root of 7 over 4. Pretend that square root of 7 is like a variable. Since both of these can be reduced with the 4, then you can technically reduce them both. What you don't want to do is just reduce one of those. You can only simplify if both parts can be simplified by that. So if that is possible, then you can do it this way as well. Okay, I'm going to go ahead and set these two up as well just to take a look at what happens, and if you want to pause and try these on your own, then press play when you're ready to check, that's fine. Okay, so number 3 should have ended up being negative 6 plus or minus the square root of your discriminant, which ended up being negative 60 all over negative 6. And so negative 60 is not a perfect square, and because it's negative, it means you have 2 unreal solutions, or we're going to have I. We're going to look to simplify the square root of 60. There is a perfect square factor of 4 and 15, and I'm going to put that negative with 4 because I can take the square root of negative 4, and it becomes 2i. So now I have negative 6 plus or minus 2i times the square root of 15 over negative 6. And then the only other thing you could potentially do from there would be to go ahead and simplify the numerator with the denominator. So negative 6 over negative 6 is really like 1, and then plus or minus I times the square root of 15 over negative 3. And that would be the most that you can do to this problem to finish simplifying. Second one, number 4 here. So standard form, when you plug everything into your quadratic equation, your discriminant should have been negative 64. So then, because it is a perfect square, you can go ahead and take the square root of negative 64. It becomes 8i. And then you can actually simplify this as well, because negative 6 and 8 both can be divided by 2. And you end up getting a final answer of x equals negative 3 plus or minus 4i for your solution. Go ahead and try these last two on your own just to make sure you're good to go, and then press play when you want to check them, and then that will be it. Alright, so for number 5, you should have had a discriminant of 73, not a perfect square, but 2 real solutions. And you can simplify that to 9 times 7, and the square root of 9 is 3. So final answer here, since you can't simplify both parts of the numerator with 6, would be negative 5 plus or minus 3 times the square root of 7 over 6. And the second one, number 6, put in standard form, you end up getting a discriminant that's 76. There is a perfect square factor of 76. It would be 4 times 19, so that ends up being negative 4 plus or minus 2 times the square root of 19 over 2. And because the 4 and 2 as the numerators can be reduced with the 2 on the denominator, you can actually go ahead and reduce that, and you end up with negative 2 plus or minus the square root of 19 for a final answer. So that is it. We'll practice more of these next time I see you guys, and have fun.